Hello, my dear. Welcome to IMS GATE Academy. I hope you are all good and your preparation going in a right direction. I am Pragyabrat Tripathi. So today I will again in front of you to discuss some important theory along with the some important GATE question PYQ, which is really very important. Okay. So first, in study sessions, in previous session, we will discuss about the work transfer, thermodynamics work transfer, quasi-static process, properties of thermodynamics property, what is the system, isolated system, what is the characteristic of the isolated system, such type of the things we will already covered. Okay, but I will give one thing is that, see, if there is any displacement work is there, that means, see, so we displacement work, that means what we will discuss, that means work done. See beta, what is that? Work done due to displacement of a moving boundary. That means when the boundary will displaced, in that case this work is associated. We will discuss, we will think like that. This is why, because I am telling you, this is very important. Why? Because beta, many of you get confused here. What is that? See, what is that? See beta. See this one. That means, see beta, if, see, very important, if there is any, see, if, one second, see this one. If this is your container, right? See this one. If this is your container, okay, okay, this is your container. Now, and this is your container, and there is one inlet is here. There is one inlet is here. This is your one inlet. Let's suppose this is your one inlet in which the fluid, is in. In which the fluid is in. Okay, the fluid is in. Okay. See, if the fluid is in, so this is obviously control volume. This is control volume. That means it behave as a open system. Right? And this is your control surface. Control surface. Yeah, boundary. Okay. Now, when the fluid, see, when the fluid is in here, there must be, and let's suppose this is our rigid. This side, this is your rigid wall, this side your rigid wall, and this side your rigid wall. Okay, these are all are rigid wall. So when the and these are not a rigid wall. Okay, these are flexible. So when the fluid is in here, obviously this fluid will, this is the rigid wall. So this wall, this two vertical wall and one horizontal bottom horizontal wall are a rigid. That means it is fixed at that location. So there is no any chance to move, but it is a movable body. So due to pressure applied, fluid pressure applied, this boundary will displaced. That means this boundary will displaced. So during the displacement of a boundary, the work will done by the system to the surrounding. That is boundary work. It is integration P dV. This is so it is not necessary that it will be applicable for open system. No, where the boundary will displace, that means displacement of a moving boundary. That means displacement of a moving boundary for a simple compressible substance, and the process is and undergoing a quasi-equilibrium process. There are three lines. Okay, now, So, so what is that? What is that, beta? That means thermodynamic work or moving boundary work or displacement work or quasi equilibrium work, these all are same. These all are same. During that, the work will transfer. It is visible. 1 second, I will take red color. That means work transfer dq is equal to integration. That means how can we write? This is very integration P into dv. Okay, P into dv. This is very important. Now, so what is that, beta? P is the property. That is which property? Pressure is the which property? Extensive property or intensive property? See, very important. In the previously, see, pressure is the, see, pressure is the intensive property. Okay, and volume is the extensive property. So pressure is intensive property, volume is extensive property. Okay, volume is extensive property. So my dear, in this case, this is your extensive and this is your change in so this is your intensive, not extensive. Sorry, I'm very sorry. This is your so this is your intensive property, and this is a change in extensive properties. Okay, change in extensive property. That means this is your displacement work. This is your displacement work. That means a displacement work, it is the product of intensive property and change in extensive property. This is very clear, no problem. Right, how can we write? If we write work 1 to 2, this is the process 1 to 2. If you write, this is you write like that. V1, this is volume, V2, P dV. This will like, and mind it, this pressure is positive, absolute pressure. This is absolute pressure, okay? And it is not constant. It will vary, okay? So you may write like that. And again, you can write like that. boundary work WB is equal to, you can write this one also, integration P dV. So these are the three fractions. This is work infinitely small, this is total, this is what. So all these are. And one thing is very clear, what is that? One thing is very clear, what is that? This work, see, this work is not a property of the system, okay? Not the property of the system. And this is not in a storage form, it is your transfer form. That means this work is the boundary phenomena. Boundary phenomena. That means it is in transient, energy in transient. That means it should cross the boundary. That means this is your path function. What is that? Path function. Path function. Okay. So this point is always keep in mind. Okay. This is your path function. So these are the very important things. Okay. So probably we can discuss, and this is due to the displacement in a boundary and the displacement in a quasi-static manner, and the system is simple compressible substance. Okay, this is clear now. Now, one of the other thing work that is very confusing, and you probably that work is related to the fluid flow, and this is also called beta. That means in this case only the displacement of a boundary is there. Only the fluid boundary displaced, it is not moving. Fluid not moving, boundary will displaced. Fluid not moving, boundary will displaced. So in that case, that is called non-flow work. Very important. That is also called non-flow work. Non-flow work. Okay, non-flow work. That is also called non-flow. It is visible. Yes. That is also called, it is non-flow work. Okay. Now, now this is the work which is in transient. That means this is your path function. Okay, this is your path function. It depends upon the path. If there is a different path have a different work, that means that gives the area under the curve. Yes, PdV work is applicable for every system. It is not, see what I am telling you, these are the definition. See, work done due to the displacement of a moving boundary for a simple compressible substance undergoing quasi-equilibrium process called displacement work. That's it. There is not necessary that this is applicable for which system. This is not applicable for which system. It is not related to the system. It is related to the process, which process is going on, and during the process, what is the boundary? That is related to the boundary of the system. Okay, that is related to the boundary is open or the boundary is closed. It is not like that. Okay, that means the system is open or system is closed. It is not like that. Okay, so you don't confuse that, sir, this is applicable for only closed system. Yeah, this is applicable for open system. No, it is applicable only the displacement of a boundary. That's it. Only displacement of a boundary. If there is anywhere in any system, if there only displacement of a boundary takes place, that work is related. Yes, it is also applicable for open system. See this one. This is your open system. This is your open system. Oh, I think you join, Atul, I think you join little bit late, so that this is open system. Yes or no? So there is a displacement is there. This boundary will displace, these two boundary are rigid and this boundary are displacing, so will displace. So in this condition, what is the work will associated by the displacement of the work? PdV, though there is a system is open. Okay, it is clear? It is clear? It is clear, Atul? Is there any confusion? Please ask me. Okay, so only there is a displacement. Okay, only there is a displacement. Okay, no problem at all. And see, very important. And already we told that it is not necessary that only displacement. Displacement against resistance. This is very important. See, this is the displacement of a boundary. Yes or not? If we take this is our boundary. If you take this is our boundary. If you take this is our boundary and we make different partition, if you remove one by one of that partition, the boundary will displaced from this partition, so this partition, boundary will displace. So boundary, though there is a boundary will displace, but there is no any work transfer. Why? Because it is no resistance. So displacement of a moving boundary against resistance. This is very important. Against. That's why this is called thermodynamic work. Thermodynamic work. That's why that is called thermodynamic work. Now, okay, it is clear. Okay, and these are the few things which I already covered. Okay, now now we take this is your non-flow work. With respect to which sense? See, many students get confused here. Sir, this is non-flow, that means closed system. No, it is not like that, beta. I give you, that means I give you one challenge that you can show me that this work is applicable for closed system. Write that. There is no any written. In a standard book, there is no any written. Okay, only local notes you can see in that condition, but that is not good. Okay, if you think like that, there is a very dangerous. Okay, so that this is very important. Okay, actually non-flow work, it is not kind of a closed system. It is related to the flow of the fluid. That means there is no of the fluid flow. Only there is a boundary displacement. No fluid will flow. Okay, that means this work is related to the displacement of a boundary. That means, see, if you have a balloon, you have a balloon, and if you blow the air inside the balloon will expand. Okay, so during the expansion of the balloon, there must be resistance against atmospheric pressure. So in that displacement of a balloon, of the elastic material of the balloon, that balloon will done a work on the surrounding. That is also a displacement, though there is an open system. You are blowing the balloon, that means you are something entry to the system. That means entry to the system, that means mass will enter to the system, that means there is a mass entry, so it is open system. So in that condition, you are taking a breath. When you are taking a breath, your stomach is now moving, and that stomach, during the moving of the stomach, you have to work against the atmosphere. So there is also a open system, and there is also a displacement work. That means your stomach, what is the work will done? See, I am asking, when you are taking a breath, what is the work will done when your stomach, while we are breathing? So while we are breathing, my stomach will work on the atmosphere as a displacement work. This is very important. That means stomach will displace surrounded air. Stomach is what? We are as a cylindrical body. So cylindrical body will expand when we are taking a breath. So during the expansion, we are work against the atmosphere, and during the expansion, our boundary, that means our body, our system boundary will displace. That means that displacement against air resistance. So there must be a thermodynamics work. Okay, that is also, but we are open system. I am taking a breath from surrounding to the system. But while taking a breath, our stomach will be expansion and contraction. During that, our expansion and contraction against the atmosphere. During that condition, we also done a work as a displacement work. As a displacement work. Okay. Now, so this is very clear. Okay. Now we will solve this. Now we will solve little bit very good problem according to the on the topic of thermodynamic work. So it is very clear. Now go to the next work, that is called flow work, right? Flow work. What is that? See, that is called flow work. So how to assume a flow work? How are your analysis of a flow work? See, my dear, this is very important. What is that? I give you one thing. See, in general, beta, this is your pipe, okay? So this is your flow work, yes or not? Flow, that means fluid can be flow. So this is a flow work, not non-flow, number first. That means fluid will in or fluid will out. Yeah, fluid will in and out. Three situations is that. So there must be a flow. That means if any system, right now I'm saying any system, if in there any system, if there is a chance to fluid in or fluid out or fluid in or out, during that condition, fluid itself exerts a force due to the pressure. That means if there is any channel, this is any channel or any system, and this system, see, if the fluid is in and the fluid is out, any type of system, and when the fluid is in and fluid is out, must be a control volume system, okay? Control volume system. This is a control volume system. That is called control surface, okay? So when the fluid is in and fluid is out, the fluid is flowing. So the fluid flow, we know that due to pressure difference. We know that. That means fluid will flow due to the pressure difference. That means what is the fluid is in and that fluid will out, there must be a pressure gradient. Due to that gradient, there will be a chance, there will the potential gradient. What is the, when the fluid is moving, what is the potential gradient? Pressure change. Pressure change is a type of gradient, potential. Due to that potential difference, fluid will flow. Electricity will flow due to the potential difference, okay? Like that. So while flowing the fluid, see, let's suppose this is your channel and the fluid is flowing. Let's suppose we take a 1 cross section, this 2 cross section, 3 cross section, 4 cross section, like that, okay? And at this cross section, this is inlet, and this cross section there is outlet. So how to maintain the flow? How to maintain the flow? If you want to this, suppose this is your imaginary column of the fluid. This is imaginary column of the fluid. This is imaginary column of the fluid. This is imaginary column of fluid. And there is any system in which this imaginary column you want to enter it. Yeah, you are entered. So what is you done? There must be a pressure. Without pressure, you cannot. The fluid cannot be flow. Fluid flow, there are different mechanisms, but flow work without pressure, the flow work is not associated. Fluid flow in the different manner. This is not, you cannot confuse that fluid is flow only the pressure difference. No, fluid will flow in many different form. We will discuss in the fluid mechanics, okay? But the flow is only due to this flow work is associated with the pressure gradient, okay? Number first. So that means this fluid if you want this fluid to move, this fluid try to push this fluid layer, and this fluid is try to push this fluid layer, and this fluid try to push this layer, so that this layer will enter into this. That means this is a pushing kind of the work. This is a pushing kind of the work. That means one imaginary fluid layer, imaginary fluid column will push the another fluid layer column, and that another column will push the further next another fluid column, so that the fluid will flow will maintain. Like that, you are in a queue and you're taking a ticket on a counter. So if you maintain the queue, that means what is mean by maintain the queue? That means if you want to, queue will move. So what my observation, what I am thinking, I will try to push the in front of the person, and that person will push in front of that person, and that again that person will push in front of that person. So during that activity, the queue will maintain. So it is that like of the force. That means it is a pushing kind of things. It is a pushing kind of work. That means this is a pushing kind. It is not like a displacement kind. It is a pushing kind. That means one layer will push to the another layer will push next for another layer, so that this flow will maintain. Flow will maintain. That means if you want that fluid have a flow, if you want that fluid maintain have a flow, there must be a flow work. You are not giving anything. Itself it will induce. Why? Because you want to the flow. So if you want to the flow, this flow work will associated. And frequently in the fluid mechanics, this is also called flow energy. This is also called flow energy. This will herd in the fluid mechanics, and this will herd into the thermodynamics. See the beauty. They are both are the brothers. They both are brother to each other. Okay. So flow work in the fluid mechanics, thermodynamics, and flow energy in the fluid mechanics. Both are the same, and both are the responsible to maintain the flow due to the pressure difference. Both are the fluid, both are the energy which is maintain the flow due to the pressure difference. Okay. So what is that? See, the work or energy required. This is the very important. Push. This is a very important. Push the mass or out the control volume. That means this is related to the open system. This is fixed. That means flow work is related to the open system. Open system. That means it is not related to the closed system. So if it is open system, that is called flow work, not non-flow. Flow work. Flow work. That means there must be in or out. Okay, no problem. This work is necessary. ये जरूरी है. This is necessary. This is required. This is necessary. ये हमें चाहिए. This is necessary. ये बिल्कुल this is not sufficient. Necessary for maintaining continuous flow. That means if you want to in out continuously, this work must be there. You cannot ignore that work. Okay. So throughout the control volume. So there are few important line. Important line is what the important line? It is a pushing kind of the work. This is very important. It is not a displacement kind of work. It is a pushing kind of work. Okay. Number second, it is pushing kind of work to maintain continuous flow. That respect regarding this flow will be present. Okay. Now, what we will do here, see, It is visible. Okay. So see beta, if there is any control volume, that means open system, this is a control volume, this is a control volume. Okay. So this is our control surface. Let's suppose this is our control surface. Let's suppose this is our control surface. Okay. Let's suppose this is our control surface, and that means this is our system. Okay. This is our system. Okay. This is our system. Okay, no problem. Now, if you want to the fluid into the system or out to the system, we have continuously pushed the fluid. How to push? Think like that. The pushing is an imaginary piston. How to imagine this piston is imaginary? See, if we want to push this fluid element, if we want to push this fluid element into this control volume, immediately back of this fluid element, there must be a fluid column which is trying to push. So we assume that this fluid element act as a plunger piston. This fluid element nearby this fluid element act as a plunger piston which is try to push. So this is nothing, this is a fluid element, imaginary fluid. See, this is your imaginary piston, so that it is an imaginary piston. That means due to this imaginary piston, we want that this fluid chunk, that chunk have a length L and volume V, pressure P, mass M. We want that this chunk will into this control volume. Same like we want that this control volume is pushed. So if you take this as a piston, so if the piston will push, if you want that to push the piston, so on this control volume, in this direction there is a pressure. Okay, in this. And if you want this fluid will exit. Why? Because continuous flow, that means continuous new fluid is coming into this. So this fluid element will exert a force on this piston. So Newton's third law, piston will exert a force on this fluid element. So there is a very important thing I'm asking many of the students, if this is our system, in the flowing fluid, control volume system, so in this side there is a pressure and in this side there is a pressure, on which concept this will happen. So students say that, sir, there is a Pascal, that means pressure always incompressible. No, it is not like that. This is very important. This is not concept due to a Pascal or a pressure. That means pressure are always compressive, so that both are compressive. No, it is not like that. My dear, it is very important. It is only due to a pushing kind. Due to the pushing. That is not a closed or stationary. It is a movable. So if we take this as a system, so this fluid element, this piston will exert on this system in this direction. So this is our system. So on the system, we'll take on the system. So on the system, it is in this direction. That means if you want this chunk will enter into it, so piston will exert the force on this one. So we are taking on this one. So on this one, it is in this direction. And this system will, if you want that this system will exit, so this system will exert on the piston in this direction. So piston will exert on the system in this direction. So this is the direction of pressure of the control volume when there is a flow. That concept, it is not a concept that the pressure, that means there is a pressure, that means this is P into A, this is P into A. That means this is a pressure force upon, this is pressure force, this is pressure force. Yes, this is a little bit differ. This pressure is different, this we will discuss later on. But this pressure and this pressure, where the origin of this pressure, how to identify this direction. This direction identified due to pushing kind of nature. This is very important. So that in the Bernoulli's equation, beta, if we prove the Bernoulli's equation, we take any imaginary cylindrical shape of the fluid element or any type of element, and on that element we take, in this side there is a pressure, and the other face of the cross section face on this side. I am asking many of the students that where from this direction get how to define that direction. They says that, sir, there is a compressive nature. So no, it is not like that, mind it. But these are the very basic fundamental. Okay, so with respect to this flow will maintain. This flow will maintain. Okay, no problem at all. Now that means if you want to derive this flow work, how to it? Is there any confusion up to that? Please. Is there any confusion? Please ask me. Is there any confusion? Please ask me. That means with okay. That means this is our control volume. Okay, this is our system. That means this is our control volume. Okay, on that control volume, there must be a pressure, there must be a pressure will exert in this direction, there must be a pressure will exert in this direction. Okay, so in this direction there is a pressure on this fluid element. This is a imaginary piston on this, in this direction. It is clear how to identify the direction. Okay, no, it is not like that. In open system, displacement work becomes a flow work. No, it is not like that. See, yes, it may be a confusion. See, very clear, displacement work. See, beta, displacement work only due to boundary displacement. And boundary displacement, how the boundary will displaced? In this condition, beta, in this condition, there is no any displacement of a boundary. There is no system is fixed at that position. There is no compressive or expansion. Displacement of a boundary, it is like that expansion or compression. That means movement of a boundary. In this condition, there is no movement. It is a fixed in a space. It is a fixed in a space. It is not compressive. Okay? Or if you want, that's, see, this open system, there is a balloon. I've already told that there is a balloon. If you fill the air inside the balloon, the boundary of the balloon will displaced. Though there is an open system, there is a flow, but there must be a displacement. So there are two kinds. The fluid is into the it. Fluid is into, that means if there is a balloon, see my dear, 1 second, we'll change the color. If this is your balloon, and you fill it, so if you want to fill the balloon, so there must be a pressure difference. So if you want to fill, this is a flow. Okay, this is a flow, and that flow is responsible to expand. In that condition, yes, the flow work is converted into displacement. In that condition, so that in this situation, the problem will solve either the open system you assume completely or either the closed system you assume completely. I give you a one, that means this example. If you want that, this example, I will solve this example, I have one question. This example will solve if you take this is as a closed system, we assume the displacement, and this is an open system. We'll solve both of these. In this condition, if your flow is in here, there is a displacement. So in this condition, flow work is equal to displacement work. Yes, but not necessary. You are saying that in open system displacement work. No, it is not always. In this situation, there may be one inlet only. At that point, if there is any boundary will displaced, in that condition, flow work is equal to the displacement work. No problem at all. Okay. Now, so this will, okay. So there is a motion in this direction. Fluid will move in this direction. Motion in this direction. Okay, no problem. This fluid element, this is control volume, and this is at equilibrium. Let's suppose this is at equilibrium. What is the work on this system? This is a P into A, and this is a P into A. Okay. What is the work? Let's suppose this have a displacement, that means it will displaced dx. That means if you want, this is in, this is out. So if you want this control volume, we move out and take a new control volume in that place. So it will move, it will displaced at a dx distance. It will displaced as a dx distance. So W is equal to this pressure into area. This is force into dx. Okay. Now I take little bit larger, okay, so that you can very visualize. Okay, and see, we take work divided by mass. Okay, work divided by mass. And what is the mass? This is the mass. Let's suppose this is dm is the mass. Dm is the mass, and the density is rho. So we know that density is d mass by volume. Okay, and what is the volume? This, what is the volume? This volume is what? The area A into dx. This is our volume. Okay, so this is a mass. So there must be a, you divide P into A into dx divided by mass. Okay, mass. And now this P A dx, and what is the mass? We know that density area into dx. Density area into dx. Okay. Hi Sita, how are you? You are late, I think. Okay. So this dx and this dx is cancelled. You are late. Why you are late? So that means this area and this area also cancel out. Okay. You pay the fine, pressure P by density rho. So see beta, this is very important. Work, that means if you find work per unit mass is equal to pressure by density. This is very important. Pressure by density. Pressure by density. Now, we know that, so this is the density of the fluid. That fluid which is flowing, that which density? That density which is flowing, okay? And this is the pressure over which, due to this pressure, the fluid will continuously flow, okay? So, okay, now So this is called displacement work. That means work per unit mass. And what is the mass? That mass of the control volume. This mass is the mass of the control volume. Very important, I'm telling you. This is the mass of the control volume. Mass of control volume. This is the mass of the control volume. So work per unit mass is the pressure by density. This is very important. See beta, that means what we discuss, that means flow work work per unit mass. This will always defined. This is defined as a per unit mass basis is equal to pressure by density. Okay, this is the pressure. See my dear, this is the pressure visible. Okay, this is the pressure, fluid pressure at which the fluid flow is maintained, and this is the density of the fluid, you know that. Okay, and this is your flow work per unit mass basis, and this mass of the control volume. Mass of the control volume. Okay, now beta, one thing is very important here, you know that thing. See, what is that? We know that density is equal to mass by volume. We know that, and if you write like that, 1 divided by volume by mass. So volume by mass is what? Volume by mass is what? Specific volume. This is your specific volume denoted by a small v. Yes or not? So sometime density is equal to 1 by a specific volume. So 1 by density is equal to a specific volume. That means see the beauty. Pressure into specific volume. This will always seen in your fluid mechanics. You already seen in the fluid mechanics. Pressure into volume. Velocity. Pressure into volume. This is your volume. Specific volume. Specific volume. Small v. So this is your specific volume. This is your specific volume. Specific volume. So P by rho, it is a fluid mechanics, and P into a specific volume, it is a thermodynamics. So P into a specific volume will use frequently in the thermodynamics. P by rho will use the frequently in the fluid mechanics, and that also called beta. That also called this one. This also called pressure energy sometime. This also called sometime pressure energy. Okay, this sometime also called pressure energy. This also called pressure energy. Pressure energy. This sometime also called pressure energy. So this is also a pressure energy. This is a very important. That means what is that? And this will done, it is in kilojoule per kg या joule per kg. So this is sometimes this is called a specific work. That is also called a specific work. This is your specific work. A specific work. This work is required to maintain the flow. This energy will required to maintain the flow, okay, due to the pressure difference, okay. So this will done, no problem, and you know that all this thing. So this is a so what is the note point is there? This is very important. So we have to study two things. What is that? See, my dear, we have to study two things. What is that? See, okay. So one thing is that we have to study is very subtle concept is there, okay. What is that? We have to study work, two type of work. One is called, this is very important, displacement work. Displacement, and other is flow work, okay. Right point by point. This displacement work is non-flow work. Non-flow work, okay. This is your flow work. Flow work, okay. This is your movement of a boundary. Movement of boundary. This is your pushing kind. This is your pushing kind. Okay, this is your pushing kind. Now, next, the displacement work WB is integration P dV. This is your specific work is P into small v. Okay, P into a small v. Now, this is your very important. Now, the term is very important from here. This is your boundary phenomena. Boundary phenomena. Okay. And this is what? Please tell me. See, beta, this is your boundary phenomena. That means it is not a system property, but this is a property, a specific. A specific is a property. P is the property, a specific volume is a property. So it is a property of the system. Very important. I am writing in the different color. This is your, it is a system property. It is a system property. It is not a boundary phenomena. It is a system property. It is a system property. That means these are depends upon the property, but these are depend upon the boundary phenomena. This is your path function work. Path function, and this is your state variable. State variable. It is clear? Anyone? Is there any confusion? Is there any confusion? Please ask me. Is there anything missing here? Please tell me. Is there any missing is here? Right. for both system. This is for both system and this is for open system. How the flow work is property? Yes. See, first of all, this we will calculate per unit mass basis. A specific thing is a property. Okay. Now, second is the, but there is a loose sense. Second thing, pressure is the property, volume is the property, and these pressure and this wear are independent to each other. Very important. But in this condition, this pressure and this volume are dependent to each other. So it is a path. It is a point. P is the pressure and it is a property. Specific volume, it is a property. So it is a property relation, like that PV equal to MRT. But it is not a property relation. Why? Because pressure is a function of a volume. It is dependent upon the path. How the volume will change, accordingly the pressure will change. Yeah, how the pressure will change, accordingly the volume will change. So it is not a property. It is a path. It is a boundary phenomenon. It is clear? Yeah. Anything to ask? Pressure is the property, volume is the property. That means if the point is fixed, this P and V is fixed. But if the point is fixed, it is not like that. So if there is a process, and in that process, if you take any point in any state, this will fix. If you change the state, this will change. So it is depends upon the end condition in between that. Yeah, it is a state variable. When there is a point, different point have a different value. But in the same path, if a different point, it is not the same. It is gives the area. It is not given by the area. It is a differ. If in the same process, if we differ the locus, this value will change. It is clear? That means we calculate the flow work as a specific term, and this will calculate not a specific term. This is not a specific. Boundary work is never a specific work, but the flow work is a specific work, and specific things are property. It is clear? Okay. Now we will solve some problem, numerical problem, so that you have a very much confidence about that. Okay. Next. This is your one problem. It is visible. Okay. See, this is just current year question. Okay. Previous year GATE question, GATE 2013-3. There is a lots of confusion in there. See, this is not you at that time you have no any confusion in this question. Why? Because only one topic you study the displacement, so it is related to the displacement, so you can solve it. But after you solve the displacement, you study the displacement work, you study the also quasi-static work, study the polytropic, isentropy, like that. If you study rigorously in the reversible or irreversible manner, I am sure that at that junction you have a confusion. At that point, you have lots of confusion in that one, because it is a GATE question, and in your back in mind, you think that it is not a very simple question. You are thinking like that. That means you are in trap. It is a very simple question. I will give you a feel. Okay. See, what is that? This is the very big question. Question is there, but the solution is very less. Okay. What is that, beta? Consider a fully adiabatic piston cylinder. Adiabatic, but that means there is no any chance of heat. Fully adiabatic. You consider fully adiabatic. Okay. You consider fully adiabatic. Okay. There is no any chance to heat loss from anywhere through this piston also. This is also adiabatic. Okay. Piston is also adiabatic. Now, arrangement as shown in figure, the piston is massless and cross-section area of the cylinder is A. In general, the cross-section area massless friction. See, my dear, if it is not massless and there is a horizontal, so it is not necessary that you can think that this mass have a mass or this have a weight have no effect on this direction, perpendicular direction. Perpendicular component is 0. So it have a mass or not, there is no any meaning, but it have a massless. Why? Because this is a horizontal position. Horizontal, the gravity is like that, and the component of that pressure force in the 90 degree, there is no any component. So it is think like that. It is no any role of this weight of this piston. Okay, if this is in vertical manner, so the role of the piston will there, but in the horizontal manner there is no any role of the weight of the piston. So think like that. Okay, massless. And cross section area, the cross section area A, this area A, it is given. Okay, cross section area. And how to calculate the cross section area? Cross section area you can calculate easily, pi by 4 and bore diameter d square. Okay, you can get it, no problem. The fluid inside the cylinder is air. This is very important. That means ideal gas. We take the fluid as a ideal gas. Ideal gas, no problem. Ideal gas. Consider as a perfect gas. Okay, the perfect gas, there is some condition according to that perfect gas behave as an ideal gas, no problem. With okay, being the ratio of the specific heat at a constant pressure to the specific heat. Ye gamma, this is your gamma, not Y. Gamma is the ratio of specific heat at a constant pressure. That means you know that gamma is the adiabatic index, and that gamma is equal to Cp by Cv. This is given. Okay, that means the air, it is fixed 1.4, you know that. Okay, specific at a constant pressure or to the specific at a constant volume of the air. Okay, the piston is initially located at the position N. That means the position L1. That means this is your L1. That means this position is L1, initial position L1. Piston is at this position initially, and there is a air which is have a pressure P1 inside the piston. Okay, no problem at all. The initial pressure of the air inside the cylinder is, this line is very important. This line is very important, so that you have a very clear clarification. See, it is said that the inside pressure is double arrow. That is very, very high as compared to atmospheric pressure. That means inside. That means there must be a stopper is there. So this stopper doesn't allow to move further. Why? Because this inside pressure is very high. That means P1 is very, very greater than P0 atmospheric pressure initially. Okay, now where PO is the atmospheric pressure, now the stop S is instantaneously removed. What does this mean? Instantaneously removed. That means we remove the stop. That means we cannot remove like that. This one. We can remove like that. See, very important. Instantaneously removed or gradually removed. What is the difference between? Instantaneously removed matlab piston try to move fast. Not gradually removed. That means you remove little bit. That means this piston is attained equilibrium at some certain distance. But it will remove and again it will install. That is like that. It will remove instantaneously, and again after some time, again very rapid time, we install that stopper, and during that displacement there is a L2 is the displacement. Like that, think like that. Okay. So instantaneously remove and the piston moved to the position L2. Then after it is moved to the position L2. Okay. Where the equilibrium pressure, this line is very, equilibrium pressure of the inside cylinder is, where the equilibrium pressure. That means here is the equilibrium pressure, here is the equilibrium pressure. That means the pressure is equilibrium. This is very equilibrium pressure. That means where the equilibrium pressure of the air inside the cylinder is P2. That means this is equilibrium pressure and that P2 is equilibrium pressure, number first. And P2 also, this is very important, is very, very greater than P0. That means if we take a change, this P1 to P2, this is double arrow, this meaning is double arrow. That means this is also very greater than. That means a pressure change is very small. This is very. This is very important. P1 is more higher than the P2, higher than P2. Also, after you know that when you when you remove the stopper, pressure will reduce. But again, reduction is very less. How to think like that? Ki sir, again reduction is very less. Why? Because again the final pressure is very high, P naught. That means the difference is very small. That means delta P tends to 0. Think like that. Student have some confusion here ki sir, when the piston is instantaneously removed, there must be a fast movement, so it may be irreversible process. But my dear, if there is a very fast but the displacement is very low, if the movement is very fast but the displacement is very low, you consider as irreversible. Why? Because in that case there is no any dissipation, there is no any losses, very minimum loss. There are same scenario. If there is a very fast and it will displace a very minimum distance, there is no any dissipation effect. And the dissipation effect is a cause of irreversibility. But there is a very less negligible dissipation effect, so you can say that the process is reversible. That means the delta P tends to 0. You can say, yeah, this is your feeling. Delta P tends to 0. Delta P tends to 0. This is mechanical equilibrium. That means this is your quasi-static process. Quasi-equilibrium process. This is the point where you have to identify this one. Now, if you identify, very simple. So, what is that? What is the work done by the piston on that? There is again a very confusing line. On the atmosphere. That means, see beta, that means if the piston will move, piston will displace the air, atmospheric air, like a breathing. If you breathe the air, the stomach will displace some atmospheric air surrounded over the stomach. So when the stop will remove, this is a very high pressure as compared to atmosphere. When the stopper will remove, this piston will move, and during the movement of the piston, the air inside the air, atmospheric air will displaced. Atmospheric air will displace. So what is the work done? That means हमें कितना वर्क करना पड़ा इस एटमॉस्फेरिक एयर को डिस्प्लेस्ड करने के लिए, कहां से कहां, L1 to L2 तक. That is the question. That means what is the work required? What is the work required to displace the atmospheric air from L1 to L2? That's it. Okay, that means what is the work required? So what is the work required? That means, see, this is the quasi-equilibrium. That is, we know that work is equal to integration P dV at initial stage. Now it is clear. State 1, state 2, final state. State 1, what is the volume? V1. Cross-section area is same. Okay. So V1 is equal to L1 into A. What is the V2 at final state? L2 into A. So there is a volume. Okay. Now, work done to displace the atmospheric air. WB is equal to integration V1 to V2 P dV. Right? Now, very important, I'm telling you. See, my dear, here is no any relation between pressure and volume. But see, work done to displace the atmospheric air. And what is the pressure of atmospheric air? P naught, and this is our constant. Work done to displace the atmospheric air, or atmospheric air pressure is P naught, which is constant. That means delta P inside the pressure tends to, this is what? Delta P is what? Very important. This delta P is the initial system pressure, final system pressure minus initial system pressure, and this is tends to 0. And what is this? This pressure? This pressure is what? This pressure is the, if I am asking very important thing, this pressure is the system pressure or surrounding pressure? This pressure is the system pressure or surrounding pressure? Please tell me. So this pressure, it is a equilibrium pressure. Equilibrium pressure. Equilibrium with, matlab equilibrium matlab system inside and outside is the equilibrium, and during that equilibrium pressure process will happening, and that equilibrium pressure will be responsible to move the atmospheric air. And that is more, it is not like a, if we install there is a spring, so in that condition we cannot put the atmospheric pressure. If we install here the spring somehow, if we install the here spring somehow, so we cannot put the atmospheric pressure. But here is no any spring, only the atmospheric pressure. Why? Because during the movement of this piston, the outside resistance pressure will change continuously. Why? Because spring, higher the higher spring will compress, higher the higher pressure will force will develop. So outside the resistance pressure will vary. But in this condition, there is no any spring, so outside pressure will constant. So that equilibrium pressure is the atmospheric pressure. Very important. P naught. That is the point where many students get confused here. Okay, sir, how to find pressure? Why? Because pressure inside the changing, but that changing is very new, and that is according to, you have to identify the processes quasi static. So P naught V2 minus V1. Okay, and what is V1? So from here we can easily find like that, okay, sir, this P naught V2 is L2A minus L1A, so it is P naught A L2 minus L1. That's it. That means the option is B is correct. B is correct. Many see, it is not as well as a, when I read the question, this one first time, I am also get confused little bit. That is question is very easy, but the concept is very strong concept is there here. If you solve this question properly, as you study the definition of the displacement work, you can easily understand this question. Otherwise, you think all the option, when you have a study and when you get a confused here, you may know any option you can reject. You may think that this is 0, this is also 0. Yes, I will tell you preceding, when the class is going on, I will tell you how you assume that this is 0. Where is the mistake? You can take the work displacement, that work is 0. Where you can take this is as this work, where you can take at this work. These are the confusion. We can deliver. We can deliver this thing. Okay. Now, now the next problem, we'll take a next problem also. This is a problem, very easy problem. This is very easy. What is this here? This is very easy problem. What is that? This is the concept where you have to find the weight of the piston. Okay, so this is a piston cylinder arrangement. Figure has a cross section area. Cross section area it is given. Cross section area piston it is given 0.01 meter square. How to balance? And piston mass it is given 100 kg. Okay, and resisting on the stop. There is a stop is here, as shown in figure, with an outside atmospheric pressure P infinite it is given 101 kilopascal. Okay, what should be the minimum oil pressure? That means P what required to lift the piston. That means you just lose the contact. That means you just required minimum pressure required to lift the piston, not a motion, lift the piston. That means just move the piston. Okay, bas sir 2 minutes, just move the piston. So we have to balance, free force balance. What is that? This is our piston. Free body diagram. You take the free body diagram. See, we already told that if you want the pressure is minimum, that means have an equilibrium pressure. Very first class. What is that? This is your piston, and piston have if you write a free body diagram, so there is, we'll take a pen, no problem. How to? This is your weight, that means mass of the piston into G, exerts a gas pressure inside it, and this gas pressure will be changing. It is not fixed. If there is a spring is there, this will gas. So it is at any instant. That means this is your gas pressure. Sorry, oil pressure. Oil pressure. Okay, this is weight, and over this there is your atmospheric pressure. And outside pressure, you can take outside pressure. Outside pressure. Now at equilibrium, at equilibrium, that means what is the pressure is required? Inside pressure P into area A is equal to outside, that means opposite, downward. What is that? Oil pressure. P infinite into A plus mass of the piston into G. This many times a student get confused here, sir. What is the physics of this equation? See, what is the physics? First of all, you say that this is the equilibrium. That means this pressure will exerted externally. That means this is the external pressure. How much the external pressure is there? So when we want to, the piston will just lift minimum. So what is the minimum? That means, see, if internal pressure is equal to the external pressure due to the weight and due to the atmosphere, there is no any movement. But what is the minimum? That means on the verge, we can equilibrium it. This is the physics. This is the physics equation, okay, at the equilibrium. So from here, we can easily find P infinite A divided by P infinite, no problem, plus mass of the piston into G divided by A. Put all this value. See beta, sometime student here get mistake here. Why? Because there is a unit. This A sometime in mm square. This is sometime in kilopascal, megapascal. So you just Very careful to that calculation. This calculation over which you have to mistake, unit mistake. So you can put all these things. So what is that, beta? Atmospheric pressure 101, and this is your kilopascal. So we'll take 10 to the power 3 plus mass of the piston 100 into 9.81 divided by 0.01. If you solve this one, this is 199,000 Pascal. And what is the kilopascal? So minimum pressure required to lift it is equal to 199 kilopascal. Thank you. Okay, we'll discuss later on.